Hello and welcome to another video in Administration of Operating Systems course. Today I will be talking about some of the utilities you will have access to in Linux and you will be using throughout this course. But first, a very brief reminder about the command line interface. So it's a mechanism for interacting with computer where you use text commands to tell it what kind of tasks you want to perform. And the most often cited reason for using command line interface is that it uses less resources than graphical user interface. And that's obviously true, and there are cases in which it matters. But the bigger reason is that it's actually more flexible for expert users. So hopefully after this course you will be able to see those benefits. In the beginning you will probably mostly see the drawbacks, but hopefully we can get you from here to here and you will be able to take advantage of those benefits. The basic idea of shell is that it's a most direct interface between user and the operating system. And the main task of a shell is to execute programs. And usually you also have some way of process or job control, so it's not just executing programs, but also being able to kill them or suspend them or doing things like that. But that's the main task of shell. As long as shell can do this, it's reasonably functional. In practice, you typically include other things in shell, things like file system access or different kinds of system administration, but those are more additional features. There are different kinds of shells. The most common one is the graphical shell, and it typically uses the desktop metaphor, where you have the desktop, the windows, start menu, taskbar. That kind of shell often includes the basic graphical library so that you can have all programs with the same look and feel. So all the buttons will look the same, all the window titles will look the same, and so on. It almost always has some kind of built-in file manager. And in GNU Linux, there is a number of different shells that are available. The one that by default comes with Ubuntu is called Unity. So if you have installed the Ubuntu on your virtual machine, you probably have this one available. But in the course, we will mostly be working with command line shell. And again, GNU Linux systems has a number of alternatives. We will be using Bash because that's the default one in Ubuntu. But you can try running different ones just to see what are the differences, and there is no problem running multiple side by side. And typically command line shell works as a simple loop, so it reads user command, tries to understand it, then tries to execute it. Once it's done executing it, it will read the next command, try to understand it, execute it, and so on, infinitely until the user gets tired of it. Now, in principle, the modern shells are complicated programs that has additional bells and whistles that are helpful for users who want to use them, but the general idea is always just this. Some of the most popular shells include SH, Bash, C shell, TC shell, and so on. But there are also some more exotic and interesting ones, like those, and it might be interesting to take a look at them and see what's so special about them. Now, it's important that you are able to access shell, so you have to figure out what's the best way of doing it, and there is a number of options. You can use Virtual Console, you can use Terminal Emulator from a graphical user interface, you can also remotely connect to a Linux system using, for example, SSH, so it's up to you how you decide to do it. Now, it's important that you take advantage of the features that are offered by most modern shells, and I would strongly suggest you get accustomed to the command line editing as well as completion and history. In my experience, those two things are heavily underused by the students, and taking advantage of them will make you make less mistakes and also do things faster, so that's definitely worth it. We will be looking at job control as well as input-output redirection already on this lecture, And some of the other things we will be mostly talking about a bit later. So for example, scripting capabilities is something that we will look at near the end of the course. As I mentioned, the basic idea of command line interface is to type commands, have them executed, and then type more commands. And the very important concept is the command prompt. So this is what indicates that shell is ready for the next command. If you don't see something like this, not necessarily exactly the same, but similar, then it means that the shell is not yet ready. And when you type a command, you specify command name, options, and arguments. And we have talked about some of those already before. But the important thing to remember is that previous command needs to finish before shell will accept a new one. So the good way of figuring out what's happening is to look for command prompt. If it's not there, then maybe the previous command hasn't yet finished. So for example, you can try doing sleep 5 and seeing what happens. Now the problem is that some commands won't finish on their own. For example, if you type Firefox, it will open the Firefox window, and until you close this Firefox, the shell where you started the web browser will not be available because the command is still running. So sometimes pressing Ctrl+C will help. It's an interrupt, so the idea is that it will try to stop the command that's executing. Depending on what exactly is happening, it's not always going to solve your problem, but it's a good thing to try if you don't know why you are not getting a command prompt. You already know that shell reads one command at a time, waiting until you press enter. You know that everything until first white space is the command name, everything afterwards is command arguments, that you separate those by spaces. I have told about different kinds of special characters. Some of them you already know, like you know what star means, you know what question mark means, you know what square brackets mean. Today we will talk about a couple more of those, but it's also important to know how to use those special characters if you want to have their literal meaning, and for that you use quoting. So you can use either quotation marks, and there are subtle differences between those two kinds of quotations mark. We will come back to this on later lectures. You can also use backslash. So for example, you can try executing command like this and seeing what happens. And coming back again to all the features that modern shell has, in slightly more practical aspects, there is something called tab completion, which is very useful. Saying that you should use it at least once per command might be a slight exaggeration, but most commands that you are going to execute can benefit from pressing the tab key at least once. It allows you to complete command names, file names, variables, and there is a whole bunch of different customizable parameters that you can be using. I actually don't remember what kind of defaults the Ubuntu has, but you can adapt this auto-completion to almost anything. Also extremely useful is arrow key history, so you can get previous next command, and this is especially useful after making some kind of mistake. So if you execute the command, it doesn't do what you want to do. Instead of typing it from scratch, you just bring up the previous command by pressing the up arrow, and then you can use line editing to just modify the place where you have made a mistake. And there is also some more advanced line navigation options. So for example, Ctrl A moves the cursor to the beginning of the line, Ctrl E moves it to end of line. You can have word-wise movements. You can cut, copy, paste parts of the line. You can also do incremental search in the history. So all those are very useful. And that's just the beginning. There is a whole bunch of other things that will make it easier for you to use modern shells such as Bash. Again, we have mentioned the documentation before, but there is a lot of it available. So on those slides, I only briefly introduce different kinds of utilities. I show some of the more important options that you can use with them, but definitely not all. So there is different how-tos, FAQs, tutorials. There is a whole big project called Linux Documentation Project, whose aim is to provide more documentation about Linux. In principle, most of this is open source, so you can actually look at the source code for different utilities to try to see what they are supposed to be doing and how are they supposed to operate. That's not necessarily the easiest thing to do, but having an option is definitely useful. Now, a lot of this information, some of those, especially tutorials, are pretty easy to follow, but a lot of it is quite technical, which uses some kind of specific language which can be difficult to understand at first. However, learning how to understand this kind of language is definitely a valuable skill and something that you will have to learn at some point in your education anyway, so why not try to do it right now? And the main place for documentation, the starting point, is something called man pages. And you can do man. In general, you do man and then name of the command. So you can try it for different commands that you already know. Try to see what information is included there and so on. But there is also other commands for getting help. It's important to remember about them and use them when necessary. So let's look at some commands in more detail. You already know pw command, but it might be interesting for you to try to understand what pwd-p means. What's the difference between this and this? Another command which you already know is cd, and for those three things here you should already understand. This one you should understand, but try to figure out what those two mean. And then, if you are interested in more advanced stuff, try to understand what's happening here. You may want to come back to this after looking a couple of slides ahead, where I talk about different variables. But this kind of advanced features are sometimes very useful. You know ls command. There is nothing particularly special here, but some of the options are going to be very useful for you within this course. Another interesting command is the file, which will display information about file type, so you can check what a particular file, what kind of file is a particular file. You already know rm. You might find the -i option interesting. You know the cp, again a couple of options that you will probably find interesting. mv, which is very similar to cp, and a command like echo. Echo is quite interesting because it will just write its arguments to the standard output. So if you do echo hello world, you will get hello world back. And on its own, it's not particularly useful. You can use it together with shell file name matching, so you can do echo star or echo star.txt to get some kind of useful results, but it's mostly interesting when you combine it with some more advanced features of the shell. So in a second I will talk about how echo is useful together with environment variables, and then later we will look at the redirection. So if you do echo $user, and that you may remember that this is one of the special characters that we mentioned before, this will display the name of the current user. And the question is how it works. So there is this concept called shell variables, where variable is basically a storage location. So there's a place where you can store some value, and each such place has a name, and then there is some value that you store within this particular name. The name has to start with a letter, and then it can have letters, numbers, or underscore character. And you always use the $character to access variable's name. So you assign a value to a variable using the equal sign, and then you can access the value of this variable using the dollar. And you can, for example, display this using echo. You can use variable names with any command. So you can use variable names with cp, with ls, or with any other command. But echo is nice because it immediately shows you what's happening. You can assign any kind of value. It doesn't have to be a number. You can say abc equals hello world. In this case, again, you need to use the quotes. And then if you do echo abc, you will get this. And I hope that you understand what's the difference between this line and this line. There is a couple of reasons why shell variables are actually useful. So for example, you can use them to store configurations for multiple programs. If you have your favorite browser and you want different programs to open web links in this particular browser, you can have a variable name which contains path to your browser, and then different programs can access this variable name and find out which browser you want to be using. And similarly, there is a number of variables that shell creates automatically and automatically maintains correct values for them. So there is a variable called home, which contains the name of home directory of current user. There is a variable called user, which contains the name of the currently logged in user. So those things are useful if you, for example, are trying to put some file in a proper directory somewhere within the home directory of current user, or if you want to, for example, display message which contains the username. Those kinds of things are useful, and using variables for that is a very easy way of working with that. Another interesting variable is, for example, path. I mentioned before that when you execute a command, most of the time the shell will have to find this command somewhere on disk or find the executable file that will be executed when you type this kind of command. And the path variable tells the shell where to look for those files. So you don't want to search the whole hard drive for a file called, for example, echo. You want this to be in some kind of standard directory, but it depends on the user where do they want to put those files. So a variable like path specifies where shell is supposed to be looking for executable files. There is a variable called pwd, which contains the current directory. And then there is, of course, this is just examples, but one more example which is interesting is a variable called question mark. And this one contains a number. And that number is something called return value. So every time you execute a command in a shell, that command returns a particular value. And that value is not directly visible. It's not something that's printed on the screen. That's not the same thing as command output. For example, if you do ls, the ls will print some number of things on the screen, but in addition to that, it will also return a number, which conventionally 0 indicates successful execution and any other value means that some error has occurred. So here is an example of how this can work, for example, for make dir command, and how the question mark variable can be useful in figuring out what happens. Now, the question mark variable is not the only way of looking at return value. There is also a way of combining multiple commands. If you want to execute a number of commands, but you only want to use enter once, or you want to put two commands on the same line, there are 3 ways of combining them, and they all have slightly different meaning. The semicolon means just a sequence. So you will execute first command and then you will execute the second command. So what happens here is you create a directory called AA and then you print finished. The AND operator will work similarly, except this one, the second command, will only get executed if the previous one succeeded. So only if the makedir was created, only if the directory was created successfully will this be printed. So in this case, it prints created. There was no such directory before, there were no problems creating it, so it worked. The OR operator is the opposite of it. So the second command will be executed only if the first one encountered some kind of an error. So in this case, nothing is printed because creating directory called cc succeeded, so there was no error, there is no reason to print error. Now, if we try this one again, makedir will complain that such directory already exists, but this one, the finished, will still be printed because we will always execute, or shell will always execute both commands. In this case, makedir will encounter an error, and then the echo will never be executed. So there is nothing printed here. And in this final case, again, makedir will fail, and then, since this is an OR, error will be printed. So depending on what you want, you will use different way of combining multiple commands. And that works for more than 2 commands. You can have however many you want. This is one of the examples where the return value of a command is going to be very useful. We will be seeing more of those examples when we look at scripting later in the course. It's also interesting to know that shell such as bash allows you to do different kind of arithmetic expressions, or not only arithmetic, different kinds of expressions. The arithmetic ones are reasonably easy to understand, but there are also some substring operations, for example, that you can be using and so on. So it's important to figure out what those things mean. And typically for most expressions, bash shell uses $sign followed by a different number and kind of parentheses. So it can be, this will be the arithmetic expression, this will execute a particular command, this will be one of the string operations. Coming back to individual commands, there is a command called cat, which, as the man explains, is used to concatenate files and print on the standard output. So most typically you are just using it to display file contents, so you will do cat hello.txt just to see what happens. But it's especially useful if you combine it with so-called input and output redirection operators, which we will look at in a second. In general, from conceptual point of view, each process in Linux has some input and output channels that allow it to communicate with its environment. So it's typically standard input, standard output, and standard error. And internally, those channels follow a standardized file-like protocol. So by default, the input is connected to keyboard and the output is connected to the screen, but actually from application's point of view, it looks exactly the same as a file. So if you think about this in that form of a picture, there is some operating system which hides from the actual command the fact that the command is talking to the screen or to the keyboard. And it's not the perfect hiding. The command can figure out what it's talking to if it wants to. For example, if it wants to display information differently, maybe using colors or something like this on the screen, than if it just puts the data in the file. But by default, it behaves exactly the same. So what that allows you to do is you can use the redirection characters to, instead of displaying information on the screen, putting it in a particular file. So just echo hi would display hi on the screen, but by redirecting it to a file, you are instead putting this text inside this file. And similarly, you can display contents of the file using the standard input redirection. This is also especially useful with some more complicated commands. One of the interesting ones is grep, which you can use to search for information within files. So on the blackboard, there's a file in which contains some information, some files on which you can try some of those things. So it contains, for example, a list of episodes for TNG, and then you can use grep to find in which episodes you could see the Ferengi. And if you know about something called regular expressions, we will not go into details in the course, but it's a very useful thing to learn about. You can also use regular expressions as a much more powerful thing than just simple looking for strings. You can look for regular expressions using grep. Another command is WC, which stands for word count, and it allows you to count words, lines, and characters within a particular file or input. So you can combine grep and word count, for example, to figure out in how many TNG episodes Ferengi appeared. And one way of doing it is to search for all the episodes, put it in some kind of temporary file, and then count number of lines within this temporary file. And then you have to remove the file as well. That works, but there is a couple of problems. First of all, you have to figure out what happens if this file already exists. This command would overwrite it, so you have to find a file name which doesn't exist, which can be sometimes tricky if you don't know what you are doing, or if somebody else creates a file with the same name, things like that. It's potentially an issue if the file gets really big, because in reality you don't really need to store this information forever, you just want to count it, so there is no reason to create a huge file with all the episodes just to count the data and then remove the file. And finally, we can forget to delete the file, and that would leave some kind of mess behind. So there is actually a better way of doing this. Turns out that this is a very common thing to do, and Linux system contains a mechanism called pipes for automating exactly this kind of behavior. So it's a simple form of inter-process communication. It basically allows grep to talk directly to WC without going through the disk. So the idea is that you use a syntax like this, and this allows you to, all the output that would be produced by the grep command, it doesn't go to the screen, it doesn't go to any file, it goes directly to the input channel of the WC command. And you can compose any number of programs in this way. You can use something like this as well. And that's one of the reasons why command line shells are so powerful, because it allows you to have virtually infinite number of combinations. You have a number of simple tools that do well-defined things pretty well, and then you can combine them to make something much more flexible. For example, you can use command like less. This is a command which is very often used together with pipes. You can use head, tail, unique, sort. All those utilities are things called filters, where the idea is that they take some input, modify it in some way, and produce output. and they are designed in such a way that you can easily combine multiples of them into some kind of chains to achieve a lot of very flexible results. Another utility which is worth knowing about is diff, which you can use to compare different files, for example, like this. It's interesting to know about different ways of finding files. If you know that you are interested in some particular file but you don't know where it is, there are different ways of doing it. So you can use which to search for executables within user's path variable. You can use whereis, which will search the standard locations. You can use locate, which is fast because it uses a pre-generated database of files, but it's not necessarily up to date because it requires the update db command to be run. You can use find, which searches directly on disk. It has a somewhat unusual syntax, so it's not obvious how exactly to use it, but it's very powerful because you specify separately some global options for the find command, the tests which define what kind of files you are interested in, and then actions which specify what you want to do with those files. By default, it will print them, but you can move files, copy files, delete files, and so on, all directly using the find command. There is a number of utilities for compressing and archiving files, and there is a whole bunch of other interesting commands. Here is a couple, but that's very, very far from all the things that are interesting. One of the other things that I wanted to talk about as far as shell is concerned is the job control. So by default, commands run in something called foreground. So whenever you execute a command, the shell will wait for it to finish, and you basically cannot do anything before that happens. Now, other than foreground, you can run programs in background, and in that case, the shell will display the prompt immediately, and the command will continue to run kind of hidden from view. So if you execute sleep, you will have to wait for 5 seconds before you can do anything else. But if you run it in background using this ampersand special character, then you can keep using shell and the sleep command will be running in background, and then after it finishes, the shell will print that this particular command has finished. And if you look at how it works, you can see that there are two numbers that are displayed here. So one is the job number, while 9000 something is the process identifier. And in general, there is only one foreground, so you cannot have multiple processes running in foreground. But what foreground allows you to do is to use input and output. If you have a task in background, it will stop if it tries to get input from the user. And from shell's perspective, job is a single task, and in general, it's a little bit more than a single process. It's something that makes sense from user's perspective. So if you write a pipeline like this will be a single job, but there are 3 different processes that's running here, all in parallel. So ps is the command you can use to display process information, and jobs is commands to display jobs information. And for job control, there are also some shortcuts that you can be using in order to control what happens. We have already talked about Control C, so this is command for aborting a foreground job. There is Control Z, which you can use to suspend a foreground job, so it will stop executing and basically wait until you tell it to continue. And then when you want to tell it to continue, there are 2 ways of doing it. You can tell it to continue in foreground or to continue in background. And you can use kill command to kill a particular job or process. And for process management, as I mentioned, there is a ps and kill command. All of them have different parameters that you can look at. And once more, as a reminder, there is a number of different ways in which you can be getting more information. I hope you already remember it and are getting tired of me repeating it all the time, but it's really important that you know about those things. And one final tool I wanted to mention is some kind of text editor. It's not a single tool, it's just a family of tools or different ways of doing a particular thing. So the thing that we are interested in doing is editing text files. You will be using it a lot of times throughout the course, especially for editing configuration files and for writing scripts. So it's important that you figure out a reasonable way of editing that. Now, the important thing to note is that this is not the same thing as text processor. So we are not talking about Microsoft Word or OpenOffice Writer. Those tools use special file format, while we are talking about editing files which are pure text. So they have nothing except the actual characters. So no information about fonts, colors, or anything like this, no tables inside. It's just simple letters and numbers. And one of the simple but reasonable text editors is, for example, Nano. So that might be a good starting point for you. And you type Nano and then file name, and it will start editing a particular file name. So it will display the current contents of the file, it will allow you to change it, save it, and so on. And most of Nano's commands are invoked using the control key, and there is some basic help at the bottom of the screen that will tell you how to get started. Now, in general, editors like Nano are pretty simple, but there is a number of more complicated tools. One which is worth looking at, it's pretty complicated, is something called Vim, or VI was the original version of it. And the interesting thing about that one is that the modal editor. So it has two different modes. It has insert mode, in which you are actually typing text, and then it has command mode, in which each character is a different command. So you start in command mode, and then if you want to enter the insert mode, there are a couple of ways of doing it. You can press I, you can press A, you can press R, and each of those will put you in the insert mode in a slightly different way. And you can use escape key to exit insert mode, go back to command mode. The problem with Vim is that it requires quite a bit of learning before you can use it. For example, obviously the command to exit without saving changes is :Q exclamation mark, and the command to exit with saving changes is capital Z, capital Z. Now, that's not the only possibilities. The nice thing about Vim, however, is that it's a very powerful editor. It has a lot of different options, a lot of different features, and you can do a lot of really efficient text operations within that kind of tutorial. And it actually has an online tutorial called Vim Tutor, so you may want to look at that. Another very powerful editor is called Emacs. It's described as the extensible, customizable, self-documenting, real-time display editor. The interesting thing is that development of Emacs started very early within the GNU project, so back in the 80s, and it's actually one of the flagships of the project. It's one of the most famous results from it. It's fully programmable in a language called Lisp, so some of the lower parts of the actual editor are written in C, but you can use high-level language called Lisp to customize almost any aspect of the Emacs behavior. So you can adapt it to your needs in a very, very nice way. There is a huge amount of third-party libraries for Emacs, so you can use it for almost anything. There are some people who are actually calling Emacs more of an operating system, because you can run almost anything you want to do, you can do within Emacs. So that's a bit of an overstatement, of course, but it's kind of interesting how that works. In General, the thing that Emacs is probably most famous for, or infamous depending how you look at it, is the multi-key shortcuts. So for exiting, it's pretty simple, it's just Ctrl X, Ctrl C. But there are some commands for which you have to press 5, 6, 7 different keys in different combinations in order to do it. But that also, on the other hand, shows you how many commands there are. Because if you need that long the shortcuts, that means there has to be a lot of commands that you can be using. Emacs also includes an interactive tutorial, so you can use Ctrl-H-T to access it. And in general, for this particular course, you don't really need neither Vim nor Emacs. Nano is going to be perfectly fine. But in general, especially if you consider a career which is related to computers in some way, learning one of those powerful editors is definitely going to be worth the time. They have a pretty steep learning curve. It takes time to figure out what to do with them. But the benefits that you get, those are things that you will be using your whole life. They will grow with you. So as you become more experienced, or if you move from one area to the other, you can always use text editor for doing important things. And that's it for now. I will see you on the lecture.